Lesson 29, Heat and Temperature. Heat and temperature is going to be yet another whole area of physics. So we've already taken a look at mechanics, some electricity, some waves, and now heat and temperature. And heat and temperature usually fall under the category of what we call thermodynamics, with thermo meaning heat or temperature. Let's take a look at our objectives. The first is that we want to define what it is we're going to be studying. So you want to be able to define heat as well as temperature. And since heat and temperature are going to be defined separately as two different things, you'll want to be able to tell the difference between the two. You will also want to be able to identify various types of thermometers, as well as to tell the difference between the various temperature scales and why we would use them. Lastly, you want to be able to convert between these various temperature scales. So let's take a look at heat. And actually, before we even look at heat, we need to take a look at what we call internal energy. All objects have energy inside of them. You know that there are two types of energy, kinetic energy and potential energy. Potential energy being stored energy, and kinetic energy being energy of motion. Because everything is made up of molecules, those molecules have energy stored inside them, so they have potential energy. Also, everything is also moving around. Those molecules are always moving. Even though the object may look stationary, the molecules are still moving, even if they're only vibrating. So they have kinetic energy. So internal energy is the sum of all the kinetic and potential energy of the molecules that make up a particular substance. Now, heat is when that energy is transferred from one thing to another because of a difference in temperature. We didn't get to temperature yet, so we can suffice it to say that heat is the transfer of this internal energy inside of a substance. And it always flows from high internal energy to low internal energy. It's like a waterfall. Water always falls down a waterfall. It never flows up a waterfall. So when you take your hand and you touch the table, you have more internal energy in your hand than the table does. So the energy flows out of your hand. So the table feels cold. So what you feel as cold is really a loss of some energy. When you touch something and it feels warm or hot, it has more energy and it's transferring from its high energy to your low energy. But the energy always flows from high to low. For our unit, since heat is energy, it's going to be measured in joules. Now, there is a throwback unit. Before people realized that heat was actually energy, it was measured in another unit called calories. So don't be surprised if you see calories from time to time. Now, in everyday language, we have a tendency to equate heat and temperature. But in science, they have two very different meanings. So heat and temperature are not the same thing. So what is temperature? Well, since everything is made up of these molecules, and those molecules are moving, any two things that are the same temperature means that the molecules of those substances have the same kinetic energy. So in a room, the air and, say, the table in front of you would have the same temperature. They're obviously made up of very different kinds of molecules. So if I plucked a molecule of oxygen out of the air and found its kinetic energy as it was moving around, and took a molecule of the table and found its kinetic energy because it's vibrating, they would have the same kinetic energy if they were at the same temperature. And that's what temperature means. Temperature is the measure of the average kinetic energy of the molecules of a substance. When two things have the same kinetic energy in their molecules, they have the same temperature. And we measure temperature using what we call a thermometer. And we have different kinds of thermometers based upon what we use. So some types of thermometers, especially ones that you might be familiar with, are things like a mercury thermometer or an alcohol thermometer. These are the kind of thermometers that have a glass bulb on the bottom. The mercury has a silver liquid in it. Alcohol usually has something like red or blue. Alcohol is actually clear and it's dyed. But the mercury and alcohol go up and down the tube depending on the temperature. Now, we end up with a slight problem. You may remember from the very first Bill Nye that you watched, Bill Nye took a thermometer and he stuck it in some molten lead. And the thermometer exploded because the mercury inside boiled. And when it boiled, it made the glass break. So we can't use a thermometer like this to measure very high temperatures. Mercury and alcohol also both freeze at around negative 40 degrees. So if you need to measure something extremely cold, you're going to be out of luck because you'll end up with solid mercury or solid alcohol. So what do? Well, we have something that's like a helium thermometer. And regular everyday helium is kind of unique in that it doesn't really freeze. So it's measured to use very, very low temperatures, like things below negative 100 degrees Fahrenheit, when most other things will have frozen. On the opposite end of the spectrum, you can have very hot things. Now, when things get hot, they glow. So we have what we call a light analyzing thermometer, which is used to measure very high temperatures because when things get hot, they do glow. And by analyzing the kind of light that we get out, we can see what the temperature is. So this is useful for things like over 1,000 degrees Fahrenheit. You will need to know these types of thermometers as part of your vocabulary. Also, by the way, light analyzing thermometers have now been used to measure everyday temperatures. If you've ever seen a laser thermometer analyzes the light that is reflected back when it shines a laser at something. So there are other uses. Now, we run into a slight problem when we take a look at the temperature scales that are used throughout the world, Celsius and Fahrenheit. And the problem is this. Celsius and Fahrenheit have negative temperatures. And if we go back to our definition for temperature, negative temperature shouldn't make sense. Because if temperature is the measure of the kinetic energy in the molecules of a substance, kinetic energy can't be negative. Because it's made up of a mass can't be negative, and the speed which we're squaring. When we square the speed, we can't get a negative. So you can't get a negative number out. So really, temperature shouldn't have a negative number. So that's why we have what's called the absolute temperature scale. It is designed to have no negative numbers. And we have an absolute 0 point, a point where 0 means zero kinetic energy. So absolute 0, what we call absolute 0, is the lowest possible temperature. It's the temperature at which all molecular motion ceases. The velocity would be 0. If the velocity is 0, the temperature is truly 0. You can't go any lower than this. This temperature is called 0 kelvins, or it turns out to be negative 273 degrees Celsius. You'll note that kelvins doesn't use a degree symbol because 0 is 0. The degree symbol for Celsius and for Fahrenheit is because 0 isn't truly 0. One other thing to note is that the size of 1 Kelvin is the same as the size of 1 Celsius degree. So if you go from negative 273 Celsius to negative 272 Celsius, you've gone from 0 kelvins to 1 Kelvin. All they did was shift the 0 point. Now here are the temperature scales that are most common. We have the Fahrenheit temperature scale, which is used in the United States, the Celsius temperature scale, which is used everywhere else in the world, and then the Kelvin scale, which is used in science. You should know the temperatures at which water freezes, boils, room temperature, and body temperature for Fahrenheit and Celsius as part of your vocabulary, so they will show up on quizzes and tests. One other thing to note is that between the Celsius and Kelvin scales, notice that they all differ by 273 because, once again, we just shifted the 0 point down 273. For your last objective, you should be able to convert between various temperature scales. The symbol that we use for temperature is a capital T for temperature. We put a subscript after for which temperature scale, F for Fahrenheit, C for Celsius, K for Kelvin. The first two formulas for Fahrenheit and Celsius are really the same formula. They're just rearranged. So if you have Celsius and want Fahrenheit, you'll use the first formula. If you have Fahrenheit and want Celsius, you'll use the second formula. Notice the parentheses in the second formula. They're very important. Make sure you use them on your calculator. The third and fourth formula are also the same formula, just rearranged. So that for the third formula, if you have Celsius and 1 Kelvin, you'll use that one. And if you have Kelvin and Celsius, you'll use the fourth. You can put these on your formula card and make a whole new category for heat and temperature. Since you're not going to have any more formulas for electricity, if you divide the electricity column in half, you can put these on the lower half of that column.